Natural language processing is the field of processing text with computers. It's been used to tackle problems like sentiment analysis, where text is classified by the tone which it describes something, maybe positively or negatively, or other sentiments. Question answering, where the system generates answers to questions. Machine translation, where the system generates the translation of some text in another language. Named entity recognition, where the system identifies particular entities within the text, and many more different tasks. To process text, we need to represent it numerically, and that consists of a few steps, which we're going to go into a lot more detail shortly. But to run through it quickly now, first thing we need to do is to split up the text into discrete atomic units, typically words. And we call this tokenization. And then we assign every word in the corpus an integer, building a map between each word and its index in the data set, like a dictionary, basically. And these indices, they are totally arbitrary, is a bit of a problem. So we would like similar words to have similar mathematical representations, regardless of what their index is in that dictionary. So to do that, we're going to assign each word to a vector, which we call a word embedding. And that's a much more rich representation of what the word actually means. Different axes could represent different high-level, complex, and useful features about those words. And we can either learn those embeddings from scratch, or we can bring pre-trained embeddings from elsewhere, maybe embeddings that we've built with another model or that someone else has already built and put online. And then once we have those embeddings, we can process them. And there are a number of different machine learning models which we can use depending on the task and other constraints, including one-dimensional convolutional networks, recurrent networks, sequence-to-sequence models, transformers, and others. So let's get into the details.